A stock analyst wondered whether the mean rate of return of financial, energy, and utility stocks differed over the past 5 years. He obtained a simple random sample of 8 companies from each of the 3 sectors and obtained the 5-year rates of return shown in the following table in percentages. We first want the null and alternative hypotheses. So, to begin with, the null hypothesis is that all 3 means are equal. So the mean of the first sample is equal to the mean of the second is equal to the mean of the third. So all 3 of these population means are equal. So this being 1, 2, and 3. I'll write them down here. So I don't have enough room up there. The alternative is that one of those means is different. So at least one mean is different. Which one doesn't particularly really matter in the case of what the ANOVA test is looking for. Just the fact that one is different. We have methods to determine that, but that is not the topic of this video. Though it could certainly always be a later one. But here we want the requirements that must be satisfied for this one-way ANOVA procedure. So we were told right here, where was it? Right here. This is a simple random sample. So we have a simple random sample. Which is good. We are not told anything about anything being normally distributed. But we could assume that that these population means are normally distributed. So the population mean is normal. We're going to assume that. The standard deviations being equal. Let me paste the data that I have into the Excel template to my right, and we can see what's going on with that. So on here, we have that the data summary shows the ratio of those standard deviations to be 1.13. So yes, we could say that these are pretty equal to each other, since that standard deviation is below 2. Then from this, we need that each of the sample sizes is at least 5. And they are, because each of these have 8 in it. So each sample size is indeed greater than 5. If we count all of these, since there's 8 in all of these, it's a total of 24. We have less than 40, but we do have more than 15, so we're good with that as well. Then we need to run our hypothesis test, which this calc tab does for us. We have ourselves a f-test statistic of 2.08 and the p-value as 0.1502. And then we can put our conclusion on here. So the conclusion from this test at the 5% level of significance, this would be at the 5% level of significance, because the p-value is greater than alpha, as in 5%, we do not have evidence to claim that any mean is different, or that one of the means is different, based upon that alpha of being 5% in this case.